All right, pre-algebra students, today our lesson focuses on solving equations with fraction coefficients. We should be able to use the least common multiple, or LCM, of fractions to aid in solving multi-step equations, especially ones where there's variables on both sides of the equation. So make sure you're following along with our guided notes and let's get started. First, let's take a look at how to find the least common multiple, or LCM, of numbers. The least common multiple we can define as the smallest multiple that several numbers share. So let's go ahead and just try to find the LCM of 2, 3, and 5. So to do that, we need to list the multiples of these numbers. Basically, to find multiples of 2, we're going to be counting up by 2. So we've got 2, 4, 6, 8. So just again, counting up by the number. I'll go up to 20 for this one. Why not? And let's go find multiples of 3. So counting up by 3s, 3, 6, 9, 12, 15, and so on. Okay. And then multiples of 5. So counting up by 5s. 5, 10, 15, 20, 25, 30, 35, 40. So right now I'm not currently seeing a multiple that they all share. So let me just go up a few more with 2s. Okay, so the more I counted up with 2s, it allowed me to see more multiples. And so I'm able to see that within the 2s, the 3s, and the 5s, they all share a multiple of 30. So this one was a lot larger than other multiples you might see, but the least common multiple of 2, 3, and 5 would be 30. And what this least common multiple is going to be useful for us is when we have an equation with fractions, we can multiply all of the fractions by the least common multiple of their denominators. So let's check out how that works and how that can make solving equations a lot easier for us. So in this equation, 7/10 n plus 3/2 equals 3/5 n plus 2. Notice how we have all of these fractions with different denominators, which means we can't really add or subtract them without changing the denominators first. Instead of working with fractions, we're going to try and work with whole numbers and integers. So to solve equations with fraction coefficients, the first step we need to do is find the LCM of the denominator of each fraction in the equation. We're going to multiply the entire equation by that least common multiple and reduce the fraction to create coefficients without fractions. We're going to get whole numbers for all of these fractions here. And then we're going to solve the equation for the variable. In this case, we're going to solve for n. So first thing, let's find the LCM of the denominators. So we're looking at 10, 2, and 5. So to find the multiples, so I'll just list out multiples of 2, 2, 4, 6, 8, 10. I'm going to stop there because I have a feeling I know what it is already. Multiples of 5, we've got 5, 10, 15, 20. And multiples of 10, 10, 20, 30, 40. And I'm already seeing that they have a multiple in common. So I'm seeing the smallest multiple they have in common, the least common multiple, is 10. What that means is we're going to multiply the entire equation by 10. So in parentheses here, we're going to take the entire equation, both sides, every single term in this grouping here, and multiply it by 10. And just for ease, I'm going to multiply by 10 over 1 so that you can see here's the numerator of 10, here's the denominator of 1. So if I were to multiply all of these fractions, let's just do that real quick. So 10 over 1 times 7/10. So the first fraction would be 7/10 n. I'm going to cross reduce. So these tens can reduce to 1. And so when I multiply across, my new fraction should be 7. My new coefficient should be 7. For the next one, we're multiplying 10 by 3/2. So 10 over 1 times 3 over 2. And here I can also cross reduce. So 10 and 2 reduces to 5 and 1. And if we multiply across, our new coefficient is going to be 5 times 3, which is 15. So 7n plus our new number here is 15. And then we have 3/5 we're multiplying by. So 10 times 3/5. Okay, and here we can also cross reduce. 10 and 5 reduce to 2 and 1. And if we multiply across, 2 times 3, that's going to give us 6. So 6n. And then we're going to multiply 10 by 2. And that one's pretty simple. 10 times 2 would be 20. Okay, so pretty much what we did here is we distributed 10, multiplied every term in here by 10. Here is the equation. It is the exact same equation as the one with all the fractions, just much simpler to solve. So let's go ahead and solve this. We want to make sure that we have variables on one side of the equation and constants on the other to solve. So just to choose that, I'll put variables on the left side of the equation, constants on the right, which means that 6n, our variable here, needs to move to the left side. I'm going to subtract 6n from both sides to do that. I'm collecting like terms. 7n minus 6n would be 1n, or just n. And I'll rewrite everything that didn't change. Next, I need to move my constants to the right side of the equation. So I'll collect like terms. Positive 15 would be canceled out by negative 15. Subtract 15 on the other side as well. This is canceled. We're left with n equals 5. So we were able to take a very complicated looking equation, make all of the coefficients and terms whole numbers and integers, and solve the equation. And promise, this is we would get the same answer if we were to work through all of those fractions. So this just makes it an easier process for us. Let's try one more. So in this one, we have 1/6 k minus 6 equals 3/7 k plus 4. So again, first step, we need to identify what the least common multiple of the denominators of our fractions would be. So the least common multiple of 6 and 7. So I'm just going to list out my multiples of 6. So 6, 12, 18, 24, 30, 36, 42, 48. And then the least common, or the multiples of 7. 7, 14, 21, 28, 35, 42, 49. So I'm already seeing that they have 42 in common. That is the least common multiple of 6 and 7. So we're going to multiply, I know this is a much larger number, we're going to multiply the entire equation by 42. And I'll write 42 as a fraction over 1. Just makes it simpler to multiply across with our fractions. So if we're multiplying every single term by 42, then let's start with multiplying 42 by 1/6. So 42 times 1/6. From here, we can actually just cross reduce. 42 and 6 would reduce to 7 and 1 because 6 times 7 is 42. So this term would become 7k. And then we're going to multiply the next term. 42 times -6. 42 times -6, that's going to be a negative number. 42 times 6 is 252. So this is negative 252. Let's now multiply 42 by 3/7 k. So 42 times 3/7. We can cross reduce here. 42 and 7, that would reduce to 6 and 1 because 7 times 6 is 42. And if we multiply across, 6 times 3 is 18. So we'll get positive 18k. And then we'll multiply, last but not least, we'll multiply 42 by 4. And 42 times 4 is going to be positive 168. So plus 168. So we're working with some bigger integers here, but that's probably much easier, more simple than working with fractions. So let's go ahead and solve this like normal. This time I want variables to end up on the right side of the equation, and I want constants to end up on the left side. So let's do that. So for my variables to end up on the left side of the on the right side of the equation, I'm going to take this 7k and collect it with the positive 8k on the right side. To do that, I will use inverse operations. The opposite of adding 7k would be to subtract 7k from both sides. This cancels. We're left with a negative, careful there, negative 252 is equal to 18k minus 7k, which is 11k, plus 168. From here, I'm going to collect the constants on the left side. So this positive 168, we're going to subtract 168 to cancel it out and do the same thing on the other side. And if we subtract here, negative 252 minus 168, that's just getting more negative. That's going to be negative 420 is equal to 11k. And so the last step of this equation would be to divide both sides by 11. This would reduce to 1k. So k is equal to negative 420 divided by 11. And we're going to get a repeating decimal here. And just know that it's completely fine to get repeating decimals. So this is going to be negative 420 divided by 11. That's a negative number, and it's 38.18 repeating. And that would be our answer for K. All right. For additional practice with problems like this, go ahead and try out problems 3 through 6 on your guided notes. Thank you again for watching. I hope this was helpful to you. Make sure that you try out some of the additional practice problems and check your answers with my filled in notes. Ask for support in Math Help Desk if you need it, and I hope you have a great day.